Sorry.
Yeah, normally I'm not as insistent, but I think that we also have some slots for discussion later on. So yeah, good morning, everybody. Thank you very much for the invitation to present today. Yeah, today I actually I was asked by Dominique to mostly present on a study we did last year to basically check what the usability issues with the current encoding are. And I thought that I could complement that with some recently started work on alternate encodings as well. Yeah, so generally speaking, the question for us is, or actually as a company, the main question really is, okay, we want to make INSPIRE successful. That means making it usable and yeah, removing hurdles that are there, technical hurdles and other ones. A work that we did in that direction last year was really to look at the current GML encoding and what are really the stumbling blocks in that. What are the small things that we can quickly adjust to already gain a lot? And that work has now been complemented by also checking, at least for some limited scope, some use cases and themes, what can we gain by also specifying an alternate encoding. Okay, so let's first take a look at the analysis of the INSPIRE GML encoding. So the context for that was the INSPIRE fitness for purpose discussions that were conducted in 2016 and 17 mostly. And we actually had a relatively small time frame for doing this. So the project started in April and was concluded pretty soon afterwards. And the idea there was that the BKG basically approached us and said, okay, we want you to really determine the concrete issues that are there in using INSPIRE data today, using current data specifications, both in terms of interoperability issues, so places where things are unclear in the specification and allow too much interpretation, and actual implementation issues, so things where the software will always have a hard time dealing with that to process the data. What we also did was we took a quantitative approach to that, so we didn't just want to suggest some things, but we really wanted to focus on those points that would make the largest impact. So we looked, for example, at how many themes are affected by a certain encoding issue, how many types, etc., to really see where is it worthwhile making some changes. All right, so yeah, so basically what we tried to do here is to create a factual basis for our recommendations, which means that we basically first looked at different use cases. So that was a set of general purpose use cases, not domain specific ones like visualization, data management, this kind of things. And then to analyze a part of the schema, so we didn't pick all 40 plus, but rather we focused on 5 schemas and specifically created data sets and then analyzed, let's say, what kind of challenges are there, where are these particular encoded examples inefficient, and so on. This is what I mentioned, the analysis of the GML instances. Then we basically created some hypotheses. That means we looked at how we can actually improve that. And of course, we wanted to test them as well. And based on that, we gave a set of recommendations. So the use cases that we looked at are, like I mentioned, more or less general ones. So for example, there's a data management use case described in there. So the question was basically, is a data structure like that something that we can effectively manage in typical systems like a relational database, or are there some typical problems going to come up? Also things like data exchange. In data exchange, for example, we want to know whether there's information loss, we want to know how big the size of the document is, and so on. So that there's other factors here. Then there's portrayal. In portrayal, I need to know, for example, if I have all my code list values as URLs, can my software actually deal with that? Can I use IGMAP, for example, to create a proper map using these rather longish and complex values or not? And of course, there are also some others. So there are some structures which might be problematic in data analysis or publishing as a view or download service. Yeah, so what we also did was basically to really look, let's say, at an analysis of the actual schema and the data to determine whether there's maybe some unnecessary complexity in there in some places. So for example, we have quite a few places where there's a very deep nested structure, and then there's actually like one value at the bottom. So that, for example, that looks like a candidate with a bad structure to payload ratio. We also looked into things like how much are references being used, how much are base types being reused. We looked at choices and substitution constructs. So, for example, substitution is not supported in our software that parses the GML, so that can be a problem. Yeah, and we then also made some statistics. So we were really interested in seeing what is actually being used in real-world data and what are places that are maybe overspecified, because that's also there. So often you have in any data model that you make, you can have underspecification, but also overspecification. And there's some typical telltale signs that if you look at how the data model is used, you can identify these things. We also looked on geometry properties usage. So the question is basically, how do the allowed geometry types create some issues in harmonization, or whether some are actually not used at all. So in some places I can use complex geometries, but actual data might not use them. Yeah. To basically go through this process, what we did was to identify the issues, determine the hypothesis, and then implement tests for them. We used a model and data-driven approach. So that means we took basically the original model and transformed it, applying some specific rules. For example, for simplification and for let's say smaller and bigger fixes to the encoding. And then to directly see, okay, does that, for example, reduce element depth? Does it reduce file size? Does it improve portrayal and things like that? Yeah, so here's an example again. So here, for example, we have a list of the base types used across all schemas. We did that because we wanted to know that if we adjust one of those, does it really make a lot of difference? Or is it maybe like an edge case? So don't need to read it, but basically making a choice to this type obviously wouldn't have a lot of impact overall. Yeah, so basically there were quite a few issues that we identified going through this process. For example, in the data management area, there are some things which make all our life harder, which create a lot of extra configuration effort, for example. It's not that these problems are insurmountable, none of them are. So all of the technical problems that we see in the INSPIRE world are, of course, things that we can address. Yeah? The question is just, is the amount of effort worth the specific gain or not? Yeah, and things like, for example, for data exchange, resolution of file external references can often be a challenge. It's like when you have an href that points to some other resource. In portrayal, I think the biggest challenge is actually nested and list properties, so those are almost always not directly supported. Data harmonization, I think the main one we had was simply missing code lists. That's really something that kept popping up a lot, especially for Annex 3 themes. Data analysis, it's again complex attribute structures which you can't easily use in, for example, standard geoprocessing tools. Yeah, and in publishing, it's generally some aspect of the complex schemas and some geometry types that are not supported. Yeah, so the study also contained a list of recommendations, which, by the way, that study is available through the German pages and also, I think, through the INSPIRE MIG group. So you can go through the entire list, basically, to see what the things are that we came up with. Some are really very specific, like alternate representations for some specific elements. Others are more general, and in the more general category, we also have this last point, which is for certain scopes to simply use alternate encodings. The reasoning here is that any encoding that you create will always be best at doing something and worse at other things. So for example, I have a computer graphics background, and it would never occur to me to directly create a visualization system on top of GML. I would use some visualization cache for that, which is much closer to what the graphics system needs. And I would also use a document or relational database for the actual management. I wouldn't use the XML directly for that. The expectation that any single one encoding can solve everything would be misplaced. Yeah, however, now I'm going to the work on alternate encodings, given the time today. That's basically... Yeah, I'm just going to give a short frame more or less for that, but I would still like to do that. I hope I'm not going to take away anything from you. Yeah, like I said, so there are the alternate encodings. That's for us, that's one way you can address certain use cases better. So basically what we believe there is really to clearly define what the scope of that alternate encoding is going to be. So for example, everybody who thinks that I'm going to use GeoJSON from tomorrow on and then all my problems are going away, I think that's the silver bullet approach. We've seen that in IT for many years and there is no such thing. So it's really important to say, for example, we are going to use GeoJSON for consumption of smaller data sets in desktop and WebGIS. That might be the scope, for example. You will also might want to limit the INSPIRE themes addressed. So GeoJSON, for example, doesn't have any capacity for 3D geometry. By default, it also doesn't support projected reference systems, so there is some, let's say, community thing for that. And it also doesn't address coverages or many other aspects. So we would really limit the scope a little bit here. And we want to address which cross-cutting INSPIRE requirements, so from the generic model and from the individual data specifications are actually included. Yeah, an optional part, and that's the one that was also discussed a lot in the community already of that, alternate encoding would be related model transformations. So basically, that's something of which you just heard. So the approach to describe a set of rules to go from, for example, the default schema to the schema for such an alternate encoding, which might be simplified. So for example, how to deal with lists, how to deal with nested properties, whether to always resolve references and these kind of things. One thing that's really important for us is that in the end, the encoding that we define, we have a clear understanding what we optimize it for and what we can use it for. So, for example, in the web world, some of you might be doing some web development work. One thing we use all the time is called caniuse.com. It basically says whether I can use a certain feature, like here CSS grid layout, across all browsers or I can't. So as a developer, I'm always going to make the trade-off whether I can live with the fact that some Opera version cannot really deal with this feature or not. And this is something that we're also working on creating for the GIS community, and will include both GeoJSON and GML features. Obviously, what we will need here is some input from the software providers. So we're not going to do those tests all the time. We're going to do them in the next month once, but after that, basically, the input has to come either from the providers or users of the specific software packages, so that we know who's supporting what might still need to be fixed. Yeah, and so with us, I want to end basically on the note, like again, emphasizing if we are doing alternate encodings, we really need to decide what we optimize it for, what its scope is going to be, how well it can be used in current applications. Also what specific technical problems it solves. So it's really important to have it clearly in mind, what am I going to solve with this encoding? And also how far, for example, it should actually address INSPIRE requirements on things like projected reference systems, on things like 3D geometries, etc. Yeah, that's more or less it. A bit brief today, but I guess that's still okay.
Still have 5 minutes of questions, to be fair. If you have any questions.
Me?
Not really a question, but a remark. Among the difficulties, there is the use of, I will say, metadata types such as CE citation, responsible party, that I have not seen in your presentation.
They are actually in the document, yeah. So that's also one of my pet peeves. But yeah, I mean, we as creating harmonized data sets all the time encounter these elements really all the time, and we have a relatively large basis how these elements are used or not used actually. And in probably something like 99.5% of the instances, we will often have exactly one value in a very deep structure. And it's the citation, it's the temporal model, it's some other places which, for what we really deal with, are simply by far over-specified. Just
Thank you for the very interesting
interesting presentation. Your first study, the analysis of the ISNPIRE GML code for the BKG, you had certain test data, test use cases you've shown in one of your slides. Why did you look exactly those? And would you, supposing you have the impression that these are standing for the other ones that you haven't looked at? If you go one further, I think you had on there. Yeah, I think.
You mean the schemas? Why we selected the?
Why did you select exactly those?
Okay, yeah, there was some logic. So there's different geometric models required in these. So there's basically a few very simple ones, but also some that have a more complex geometry model or other challenges. So I would have to look it up again, but I think in the report it basically says why these 5 teams were basically chosen. We did also run the statistical analysis across all of them, but those are the ones that we actually worked with data from. So we reused some data sets that we had for these 5 topics to do the analysis on how the encoded samples actually look like and how much overhead, for example, is there.
And for example, why did you take transport network?
Where we didn't take transport network?
Yes.
Yeah. I have to say I would have to look that up again. Why that decision was made in the end.
I can answer that.
Yeah.
We were focusing on Annex 3 because we were trying to influence the future. Annex 1.
Thank you very much. Yes, but we thought we could, because we showed to Dominique, because there will be a discussion